Assalamualaikum and good day. My name is Azlin binti Sahadai. My final year project title is Hemp Fiber Composites, Effect of Lamination Scheme on Mechanical Properties via Ansys Simulation, and my supervisor for this project is Associate Professor Dr. Aida Timahat. The content of this presentation includes introduction, problem statements, objectives, literature review, scope of project, methodology, expected results, and conclusion. The first section is introduction, in which I will explain on the basic knowledge of fiber reinforced polymer composites. In recent years, the use of polymetric composites reinforced with natural fibers have increased due to their good properties and advantages over synthetic fibers in terms of its relatively low cost, low weight, and low equipment damage during processing. Natural fibers are the fibers that are derived from plants, animals, and minerals. Plant fibers are abundant, economical, and biodegradable, making them suitable to be used as alternative for synthetic fiber. Common natural fiber used as reinforcement in composites are hemp, jute, kenaf, and flax. Natural fiber reinforced polymer composites are used in various applications ranging from building and constructions, car industry, aerospace, and sports due to its desirable properties. The second section is the problem statements. In these sections, I will describe the issue to be addressed in this project. Fiber orientation influences the mechanical properties of the composites. The angle of orientation can result in different value of mechanical properties. Lamination schemes of the fiber composite might result in better mechanical properties. Thus, various orientations of hemp laminates will be modeled and analyzed under various types of loading. The mechanical properties of the hemp fiber composite will be compared with synthetic fiber composites such as carbon. The third section is the objective of this final project. There are three main objectives of doing this research. The first objective is to analyze the effect of layer sequence on tensile, compressive, bending, and quasi-static indentation, strength, and deformation of hemp FRP composites. The second objective is to study the effects of hole on tensile and compressive strength of hemp FRP composites. The third objective is to evaluate the effect of the supporting ply angle on compressive strength of unidirectional laminate of the hemp FRP composite. The fourth section is the literature review. In this section, I will explain on the literature review that has been done during this semester on the related topic of this project. Hemp is one of the most widely used natural fiber as reinforced material in polymer composites. Hemp fiber is a type of fiber derived from a plant called Cannabis sativa that mainly grows in Europe and Asia. Hemp fiber are found to be very cost-effective alternative for synthetic fiber due to its high strength and stiffness. Hemp fiber, also known for its elasticity, easy to process and recycling. The low density of hemp fiber will reduce the weight of the composite, and hemp fiber reinforced composite can be customized to meet a variety of specifications and different manufacturing systems. The mechanical properties of natural fiber reinforced composites not only depend on the chemical composition and physical properties of the fiber, but physical and geometric parameters of the fiber arrangement also affect the mechanical properties of the natural FRP composites. Fiber orientation is found to be the key in controlling the mechanical properties of the composites. The most common orientation in fiber reinforced composites are unidirectional, random, bidirectional, and multidirectional. In this project, only unidirectional fiber composite will be studied. Unidirectional fiber composite is where the fiber in the composite are arranged in one orientation only. varying the angle in orientation of unidirectional composites from 0 degree to 90 degree, the mechanical properties of the composite will vary accordingly. The composite with 0 degree fiber orientation will have excellent properties compared to composite with 90 degree fiber orientation. When a sample such as natural FRP composite is subjected to mechanical testing such as tensile, compression, bending, and quasi-static indentation, various mechanical properties can be analyzed. Tensile tests and compression tests are usually conducted to determine the strength of the material and the Young's modulus. The tensile and compressive properties of the natural FRP composites are highly dependent on the fiber content and its orientation. Bending test, or sometimes known as flexural testing, is the test conducted to determine the bending strength of the sample. Quasi-static indentation test is static analysis of the response of the sample when subjected to impact. The quasi-static indentation test can provide information that can be used to describe the damage of the sample during impact. The software that is used for the modeling and simulation of this project is Ansys software. Ansys is also known as Ansys Mechanical or Ansys Multiphysics, which is a software made for general-purpose finite element analysis. The software consists of various general-purpose analysis tools that have pre-processing and post-processing solver. Ansys software is used in this project to analyze the effect of fiber orientation on the mechanical properties of the Hemp FRP composite. Via Ansys modeling and simulation of the mechanical test can be done with suitable boundary condition and loading. The deformations and stress from the applied load can be simulated directly using Ansys software. The fifth section is the scope of this project. The scope of this project are conducting literature review on previous studies related to natural FRP composites, hemp fiber, and the effect of fiber orientation on the mechanical properties of FRP composites. Data on mechanical properties of hemp FRP composites are collected based on literature work. Construct the model and simulation in Ansys software to analyze the performance of Hemp FRP composites and compare the performance of Hemp FRP composites with carbon FRP composites for validation purposes. This is the scope of work in this project. There will be 6 loading types, which are tensile, open hole tensile, compression, open hole compression, bending, and quasi-static indentation. Shown is the layup sequence of the laminate that will be used in each testing. The outcomes of this simulation are deformation analysis control, stress control, maximum stress, and maximum strain. The sixth section is the methodology of the project. The methodology starts with extensive research, pre-processing, meshing or conversion analysis, and boundary condition and loading time. In order to fulfill the objective of this project, a research will be done to determine the required data and procedures needed. As this project will be done using Ansys Mechanical FPLD, the properties of the composite such as value criteria will be needed for the analysis. The table shows the properties of the Hemp FRP composites and carbon FRP composites needed for the analysis via Ansys software. When using Ansys Mechanical FPLD for analysis, preferences was set to be structural. Then pre-processing steps can be started with modeling the model. The area of the sample is defined using 2 corners area of rectangle. Next, the element type is defined as shell with add node to add 1. Then the properties of the model are defined using structural of linear elastic orthorhombic. The failure criteria are then defined accordingly. The next step will be defining the lamination schemes of the sample using shell layout according to the fiber orientation. Convergent analysis is done to determine the suitable mesh size for the analysis. Smaller mesh size will increase the accuracy, but it will increase the computing time of the analysis by the program. A series of convergent analyses are done to justify the suitable mesh size. The sample used for the convergent analysis is unidirectional carbon FRP composites with fiber orientation of 0 degree, 45 degree and 90 degree under the same compression load of 10,000 Newton. Through this analysis, 8 times 8 mesh size is chosen for this project because this mesh style is already sufficient to obtain the accurate results. Shown is the example of sample size of the FRP composite, meshing size of 8 times 8, degree of freedom and example of compression load used in the testing. The seventh section is the expected results for this project. The table shown is the results obtained for Hemp FRP composites in tensile tests. From the results, the graph of maximum stress against fiber orientation for Hemp FRP composite for tensile test will be constructed. The trend lines show that the maximum stress will decrease as the fiber orientation increases. The table shown is the result obtained for carbon FRP composites in tensile tests. From the results, the graph of maximum stress against fiber orientation for carbon FRP composites for tensile test will be constructed. The trend line also shows that the maximum stress will decrease as the fiber orientation increases. Shown are the example of contour of displacement in X, Y, and Z direction. Last but not least, I will conclude this presentation. In this research, Hemp FRP composite is chosen to be analyzed in terms of its mechanical properties such as tensile, compression, bending, and quasi-static indentation properties via Ansys software. Hemp is one of the widely used natural fiber as reinforcement in composite that is derived from plant called Cannabis sativa. Hemp fiber are found to be strong and stiff, which makes them suitable as reinforced material for composites. The results for Hemp FRP composites are compared to carbon FRP composites, which is one of the synthetic FRP composites. It is predicted that Hemp FRP composites exhibit good mechanical properties such as strength, elasticity modulus, and deformation when compared with carbon FRP composites. It is expected that Hemp FRP composites with fiber orientation of 0 degree will exhibit higher strength and modulus of elasticity, while the Hemp FRP composites with 90 degree fiber orientation will exhibit the lowest value. This research will contribute to the knowledge of predicting the strength and performance of Hemp FRP composites using simulation technique via Ansys software. This is the end of my presentation. Next will be shown the project planning of this semester as well as the references used in this presentation. Thank you.